So I wanted to take a little time to review this with you and go through some of the things that you missed. So the first one, it says when 109,857 arrests for, you can read the problem. But what I want to focus on here is they actually give us, they've already run the test for us. So the values are over here, right? I'm going to put this side by side. So we can see that we are going to be doing an inequality test. I'm going to send this to you, but I went ahead and filled out kind of a flow chart of what we're going to do. They've already taken care of identifying the null and the claim. Again, you can see that we are testing our proportion is greater than 0.29. They ran it for us because you see we are testing the claim that more than 29% of federal crimes were for drug offenses. This is the calculator display. What we're trying to do is figure out if our p-value is greater than alpha or less than alpha. Since it's a less than, we know that our claim is going to be an H1, right? We are testing that H1 is greater than 0.29. So let's test that. Let's see what's going on. I got a 0.03, right? Is that greater than 0.05 or is that less than 0.05? Well, our p-value is, it's less than, right? So if it's less than, we're going to be using, you see I have this, if our p-value is less than, we are going to reject H0. So we are going to support H1. So it says, you can see that since we are supporting H1, since our claim is H1, there is sufficient evidence to support the claim that more than 29% of federal crimes were for drug offenses, okay? So since our p-value was less than alpha, you see that 0.03 is less than 0.05, and since our claim is H1, it's this bottom box, the sample data supports the claim. So that's why we said we supported the claim. Oh, I'm sorry, I started at number 6. We're going to go back up to number 1 and take a look. So you need to put this data in your calculator. It did seem like you got your linear regression fine. I'm going to go ahead and hit pause, and I'm going to put this data in the calculator. So as you can see in my calculator right here, I have filled out the data, and now I'm going to run a regression. So what I'm going to go, after we get this put in our L1 and L2, we're going to go to Stats, Calc. We're going to go down to number 4. We're going to run that regression. Calculate, and I did not run the right regression because we should have R value, so I've got to change my calculator settings. I'm going to hit pause again real quick. Alright, sorry. So if you didn't, I went ahead and put all the data in, so hit pause and put that data into our edit. So after we get that into our L1 and L2, you see I've got my right arm in as L1 and my left arm in as L2, and we're going to go to Stats, Calc, and now we're going to run that regression, and hopefully now this will give us our values. Okay, cool. So now we've got R, and we've got our A and our X. It seems like you were able to get these values put in correctly. You can see that it's switched. You see that the A value is actually at the end, so it's 1.1. You got that in correctly, and our B value is 60.3. You got that correctly. But now, what we seem to do incorrectly is, given that the systolic blood pressure in the right arm is 85, the best predicted blood pressure in the left arm would be, what we're going to use here is dependent on whether we have correlation or not. So how many pieces of data do we have? We have 1, 2, 3, 4, 5. We have 5 pieces of data, and we're going to be using a significance level of 0.05. What we're going to do is we're going to go to our formula sheet, which I've got right here, and you're going to scroll down, and we're going to look for this correlation. So we have 5 data points, and we're using 0.05. So if we have correlation, our R value needs to be greater than 0.878. Let's take a look at our calculator. I'm going to pull this over to the side so you can see them both at the same time. What is our R value? The value of R in our linear regression is 0.839. That is not greater than alpha. R is not greater than alpha, so we do not have correlation enough in this line, so we cannot use this line. So since we cannot use our regression equation, we are going to instead use the mean. So what we want to do is we want to calculate the mean of L2. You can do it by hand by adding all these up and dividing by 5, or we can go to Stat, Calc, And when it asks for what list, we want to put L2 in there. Now, if you have a TI-80, if you have an 83, you're just going to go to one variable statistics, and then you're going to hit second and L2 right here. But you can see that the mean of our data is 156.8, so that's how we got that. So if you do not have correlation, you just find the mean of the Y values, and that's what we use to predict. All right, moving on. All right, so our R value is not greater than our alpha value. If it's 0, I mean, you can look. We have 9 data points. It's not going to predict. So take a look. In this second part of this question, we did the linear regression with just these 9 points up here. You can put it in L1 and L2. I can see that you got the value of R correctly, so I'm not going to go over how to find that. But now what you need to do is you need to take a look at our significance level. We have 9 data points, and the value we're comparing it to is 0.789. So 0 is less than that, so no, there is not correlation because the coefficient, it's not greater, right? This number, this R value needs to be greater than 0.789 if we're going to say there's correlation. Okay, so again, you were able to find the p-value correctly, 0.0051. You see this is less than our significance level. So if p is less than alpha, so you see our p-value is less than alpha. If p is less than alpha, then we reject H0, okay? So you want to select, if p is less than alpha, we're in this case, so we're going to reject H0. Since that was our claim, we ended there. We didn't have to support anything. So if your claim is H0, which you can see it is right here, we are going to reject H0. This one right here, it looks like, it says assume that a simple random sample is normally distributed. We got a p-value. In a manual on how to have a #1 song, it stated that the song must be no longer than 210 seconds. So it seems like 210 is what we're using as our claim, right? So it's going to be less than that. A simple random sample of 40 taken. We got a mean and standard deviation. So we are going to be running a z-test, or a t-test. So in our calculator, we're going to go to stat. Since we have a standard deviation, we know we're going to be using the t-test. So we're going to put that in there. What was our... So it says that we know that this must be no longer than 210. So we're going to put that in here, 210. What was the mean of our sample? We took a sample of 40 hit songs, so we know our value of n is going to be 40. So now our last thing that we need to do is, sorry, it switched screens on me. Underneath our t-test, we get all that data in there, and we want our mean to be less than, so we want to make sure we select this one that is less than, and then we're going to go to calculate, and you can see that our p-value is 0.168. Now, is that value less than or greater than our significance value? 0.167 is greater than alpha, so we are at the point where p is greater than alpha, so we cannot reject H0. H1 was our claim, so we need to go to the second step where we say there is insufficient evidence to support. So if we cannot reject H0, then we cannot support H1. So if P is greater than alpha and your claim is H1, you are going to be not supporting, or you say there is insufficient evidence to support. All right, and this next one, I think all you did was round incorrectly. It says round 2 decimal places. It looks like you put in 1. That's an easy one to fix. This is very similar to the, I think we did this one already. This is what I started on. And finally, number 9, let's take a look at this one. It says a random sample of 139 40-year-old men, 26% were smokers. Find the p-value for the test statistic that the claim that the percentage of men that smoke is 20%. So this time we're gonna run a, we're gonna go to tests, and we're gonna do the 1prop z test, because we know that, what are we testing? Our percentage is 0.22. How many of those total people did we sample? We sampled 139. Now, if 26% of them are smokers, so we have to do 0.26 times 139. So when I did 0.26 times 139, I got 36.14, so we're going to round that value to 36. And this is the test that we're going to be using, so we're going to now calculate this. And we are asked to find the p-value, which is 0.267. None of those are available, but we're going to have to go with the closest one offered to us, and you can see that 0.2542. Because of the fact that I had to round the 26% of 139, that gave us a slightly different p-value, but as you will be close, and they vary enough between these four choices that D was the one that should have been the correct answer.